Welcome everyone to our webinar Teaching Engineering Statistics. My name is Volker Kraft. I'm also with the JMP academic team and based in Germany. Some time ago I was a student in electrical engineering and a researcher in communication acoustics. What means that JMP, the statistical discovery software from SAS, is really made for us. In 1989, the first version of JMP was created with the engineer and the scientist in mind. In a nutshell, JMP is very visual and interactive and also easy to use. So it's a data analytics package on the desktop, but it also comes with its own scripting language and a full development environment and can be extended in many different ways. Today, JMP is used by industry and academia worldwide in 6 application areas. And in this webinar, I will look at applications which are also taught in many engineering courses, namely exploratory data analysis and visualization, statistics, design of experiments, and we will also see a few examples about quality engineering and reliability. And if you take this link to our application areas, you can also click on an area and you get more information and use cases, demos and white papers and more resources. So we will start with statistics today and summarizing and graphing data. We will look into statistical intervals and hypothesis testing and also model building. And later we will also have some brief examples about design of experiments and also some quality and process tools. I'm using JMP Pro version 13 on the Mac, and this is Pro 13.2. And for any difference between JMP and JMP Pro, please see the JMP Starter, select JMP Pro, and you will see the JMP Pro specific platforms and also some Pro features which are probably interesting to know. So how to get JMP? By the way, our site license called JMP Academic Suite does include JMP Pro, both the Mac and the Windows version, for all faculty, researchers and students of one department or campus-wide. And for any questions about academic licensing, please get in touch and send your email to academic@jmp.com. So what you see on the left on my screen, that's a JMP journal. And by the way, this JMP journal file will also be posted along with a session recording during the next days at jmp.com/webinar. And webinars are just one type of academic resources. And for other types, please refer to our online portal at jmp.com/teach. And this brings you to a menu where you can select different types of resources, including our Getting Started Learning Library with one-page guides and short videos, case studies with data sets and real-world problems. And I would also like you to point you to our course material pages, which are especially helpful if you consider to use JMP in teaching. So here are several different courses, and there's also a course about engineering quality and reliability. And this provides you a best of all our free resources, including one-page guides and webinars, scripts, books, and e-learning courses, and a lot more. So let us proceed to the first topic here about summarizing and graphing data in JMP. The first JMP table, diameter, is like all other data sets I'm using today from the 500 sample data sets shipping with our software. So check help sample data, and there you can find a lot of different data sets for different types of analyses or different fields of applications. And also most data sets come with stored scripts in the upper left panel, and you can just run them to see some sample analysis results by a single click. So this file, diameter.jmp, has 240 measurements in 240 rows. And the measurement is diameter. So we see here, and it has been measured by different operators, machines, on different days. So in total we have 5 variables stored in 5 columns. And especially with hundreds of variables, so this is a very small data set, but with many variables, the columns viewer is a nice tool to get an overview. A first overview about your data set, and I pick all the variables and show the summary. And here you see that for just these 5 variables we see the information about diameter, and as you see by the blue icon, diameter has numeric data on a continuous scale, and that means that this overview provides minimum, maximum, and some standard statistics. All other variables in this data set are categorical. So they are nominal, the red ones, or ordinal, which is the green icon. And for these variables, we see the number of categories and also number of missing values if there are some missing values in the data set. Looking at distribution, which is the first platform on the Analyze menu, again, for all variables, we see the distributions of all 5 variables side by side. On the left we have day, and we have 6 measurements per day, and that's maybe good to know, but it's not really informative, so I remove that one on the red triangle. And now we have 4 variables left, and again we see that we get different outputs based on the modeling type, even from the same platform, which is distribution in this case. So on the left, for diameter, we get a histogram and a box plot, and we get bar charts for the other categorical variables. So all JMP reports like this one are interactive and just a starting point for your statistical discoveries. So that means you can explore your data by clicking. So I can click on the data from phase 1 or the data from phase 2, and we directly see that all operators and machines were used in both phases. But if you compare the spread on the histogram for diameter, we see that the variation could be slightly reduced from phase 1 to 2, so that was maybe an improvement after the first phase. I can also select, multi-select data from the histogram, and you see that they are all connected. So all the outputs, all the windows, and the underlying data tables are connected, and you see how many rows are selected right now, which are 100 rows, as the data table tells us. Another way to work with reports are the red triangles you find in many places. So I can take the top red triangle and just stack the output. And in this case, you see that they are now horizontal if this is your preferred view, but it's the other way around to better use the space on a screen. So for the histogram, for the continuous variable, I can also ask for a normal quantile plot if I have some concern about normality about our data. Or on summary statistics, I can customize the statistics and add other statistics to the output, and I confirm by OK, and now you see that more statistics are shown. The third way to work with reports is just a simple right click. So I can right click here and maybe assign another color to the histogram. So red triangles, right click and select and use the dynamic link feature. So these are the ways to work with the reports. And if you want to save some defaults, if you want to personalize your JMP installation, so you can do this in preferences, and here you see that all the JMP platforms, for instance, have their own presets you can set personally. So I didn't change a lot in my installation for today. So I just used some other fonts, and for distribution I changed the histogram color. I made this blue, and I selected this separate bars to select bars on a bar chart to better differentiate against a histogram output. So that's all about the preferences I changed. Okay, let me close this one. Another platform I would like to show, the third one on this list here, is on the Analyze menu again, but it's called Tabulate. And this is a drag and drop tool for cross tabulation and summary statistics. So here I grab the diameter and drop the variable on a drop zone for columns, and we get the sum by default. I'm more interested in the mean and the standard deviation, so I replace sum by other statistics. So now I can also group and break down the output by categorical grouping variables, for instance operator, and I can also add machine, and I can also add the face to the picture. So the picture is a table actually with numbers, but it's interactive. It's a JMP table, so I can also move face maybe to the left to change the order. There's a red triangle again, so here I can also add some visual output. I can unselect uniform scaling, so to better see the different scales and outputs. And when I'm done, I click Done. And one way to save any result in JMP is on the top red triangle, choose Save this output as a script, maybe to the data table. So I choose this. You can rename the name, and it's done. So I can close the output. I can send this file to another user, to a colleague, and they will find this script here, which was added recently, and they can just click the green arrow symbol and get back to the same report, and it's again interactive, of course. So I can also get the control panel back and then start to change or modify the output again. Okay, so last but definitely not least is a drag and drop tool called Graph Builder. So this is on the Graph menu, again the first tool. And Graph Builder is definitely your best friend for any graphical summary. So let me just give you an idea. So I drag diameter to the picture, and now we see all the diameter values on the y-axis and jittered on the x-axis. But I want to see the different measurements by operator, so I put operator on the x-axis. And now we see some point clouds, but maybe you get a better overview about the quantiles if you choose box plots instead. What about the face? So I can also put the face in maybe here, or I overlay. Hey, that's interesting. So now I can really compare the two faces. And again, this confirms that the spread was reduced from the blue to the red face, I think, for all 4 operators. So that's a good sign. I can also take machine and break it down even further. So I could maybe get different outputs by machine, or I take machine and wrap by machine. So now I see everything, all the machines in one graph, and I can easily compare them. So don't forget, right click to change and customize anything. So I can change this to see one level at a time, and when you're done, you click done. And now we see the outputs, and I can look at all the machines and study the improvement from phase 1 to phase 2 in detail. Okay, so the next topic is about statistical intervals and hypothesis testing. So let me open the data set thermoplastic.jump, and here we see injection molding data from an experiment. So I start distribution again. So the response in this data set is tensile strengths, which I add to the Y columns to analyze for distributions. But I would also like to see the distribution for the 2 factors. One is continuous, specific, gravity, and one is categorical, nominal in this case, the supplier. I click OK, and we see the outputs. So we only have 3 variables, so maybe it's a good idea to stack the outputs to better see what we got. So the summary statistics for tensile strengths, for instance, and also for specific gravity for continuous variables, already show the upper and lower 95% confidence interval for the mean. But there are more options. So let me take the first variable and open the red triangle. So here you see on the confidence interval menu, I can also ask for confidence intervals with other alpha levels, for instance 90%, and we get this. So here you see that we get a smaller interval if you compare the interval for the mean, which is this one here, with the 95% one. So that's maybe what you expect. So let me just remove maybe the quantiles, and also let's remove the summary statistics to get some more space to the right. Of course, I want to show you some other options as well. So there are not just confidence intervals, you can also ask for a prediction interval. And that's the interval where to expect 1 or n, let's say 10 future observations at a given confidence, which is set to 95%. So I click OK, and here we see the prediction interval for all 10 individual data points, but also for the mean, and this is what you see right here at this confidence interval level. And the third option is the tolerance interval, and this is the question to see where to expect a certain percentage of our data, maybe 90% at a given confidence, 95%. And you also get this interval on the right. So these are important intervals engineers typically ask for. Of course, there are many more options. Some are for testing. So for instance, the one sample t-test is what you find on the distribution red triangle for continuous variable, a numeric variable. And I choose test the mean, and I could specify a hypothesized mean, let's say 7.2. I could specify a standard deviation to do a z-test. I can also add the option for a non-parametric test and click OK. And then we get the output from the t-test. So this is our hypothesized mean with its sampling distribution. And we see that it's quite unlikely to observe a mean we see in our data at this point here, the red mark. So the p-value is also quite low, so this is significant, which means that we can reject this mean here. There are also some other options. So there's also an interactive p-value animation, so to see the relationships between p-values and t-statistics and so on. Maybe nice for teaching as well. Another option at the same place is a continuous fit. So I could ask for a continuous fit. Maybe I don't know what the best distribution is, so I ask JMP to test all and give me the best. And the best seems to be the log normal in this case. So this one is already shown as a green curve. I can also add the normal for comparison reasons. And so here we see the fitted normal output. And there I can also ask for the goodness of fit. So what about the normal distribution? Is it fitting our data well? And the p-value is not small enough to have some concern, so it's not significant here. So there's no evidence, not enough evidence to reject the null hypothesis, which says the data is from a normal distribution. By the way, you can also hover on numeric outputs in JMP, and then maybe a non-statistician also gets some help to interpret numeric outputs, and this tells the background about the hypothesis test and the p-value in this case. Okay, so the next level after looking at distribution is the bivariate case, fit y by x. And this one can be used in 4 different ways. So let me show you this one. It's the second option on the Analyze menu. And in this case, so we use the same data, and I take my response in here as the y. And I'm interested in the relationship between 1y and 1x. And the 1x is the continuous specific gravity on the one hand and the categorical supplier on the other hand. So these are 2 relationships basically that tensile our response with both factors. So I click OK, and maybe before doing this you can also check the preview here, and you see what you get depends on your response. The y, is it continuous or categorical? And your x, is it continuous or categorical? And here we have both cases. So this one and this one. So this will lead us to a bivariate output and a one-way ANOVA output. And that's exactly what we see here, at least the starting points for that. So on the left we have continuous by continuous, that's the bivariate case. And the options we see here include fitting a line, and we can also look at the R-square, and this is maybe not a great fit in this case. I could also ask for a density ellipse. So this shows you the linear association between these two variables, and we can also look into the correlation we have here. So there's no strong relationship in this case. And on the right hand side, the one-way analysis, maybe let me just jitter the points. Not so many in this case, but I think this is helpful in many cases. You can add the quantiles, and you can also ask for means and ANOVA. And what we see here is that we don't really have a significant differences, and this also tells you the ANOVA output. So it's not significant here, so there don't seem to be any differences for this data set. Maybe let me show you another example, and that's the second button here. So this is data. We have cold particles measured for a certain pH numeric factor, and polymer, which is categorical again. So same procedure, I choose fit y by x, and in this case this is my response, and these are my two factors, continuous and categorical again. So now if I fit a line, so we see that this is a much better fit, and this can also be confirmed if you look at the fit red triangle and maybe plot the residuals, and you see that this is a good fit in this case. Also the analysis of variance shows some significance. And on the other side, let me also jitter the points again. So if I ask for means ANOVA, means ANOVA again, this one here, the second. So we see that the means seem to be more different for these data, and there's also some significance which shows up down here. So there's some significance between which polymer types. So you can also ask for comparing the means, maybe using a pairwise student t-test, and if the colors are different, gray and red, then the means are statistically significantly different. So if you want to be protected against some issues you may get from multiple comparisons, like in this case, so you may choose another test, maybe Tukey's honestly significant difference test, and this has bigger circles, so this test has less power than the student's t-test, but it gives us the same conclusions as the other test. So there's also an option to set the alpha level if you want to do some Bonferroni correction on your own. Okay, cleaning up a bit and don't save and moving on. So we saw the one-way ANOVA and the bivariate and regression output for two different data sets, and the last one was the more interesting one because we got some significant relationships. But I also would like to show you the other two ways to use the fit y by x platform, and for that I use a bigger data set, which is a tablet production, and here we have a categorical response, which is lot acceptance. And we have measurements of dissolution for different lots, and the dissolution has to be above 70%. In this case, a lot is accepted. Otherwise, it's rejected. And the question is which process settings are explaining or can be used to predict and to optimize the process output. So that's the question here. So I take the Fit-Y/X platform again. So still using the same platform, we will get totally different outputs and also options on the red triangles to investigate. Let me show that. So the response is lot acceptance, categorical this time, and I'm interested in screen size as a factor and also compressor as another factor, and mill time, which is continuous, the only continuous factor right now. And then for the two categorical factors, screen size and compressor, we get a contingency table and we get a mosaic plot and corresponding options, and also depending on the number of levels you get different options and different tests. So for instance, we get odds ratio and relative risk in the case of 2 levels on our factor. And on the right we have the categorical, let's start here, versus continuous case. And here we see that with growing mill time, the probability to be accepted increases. So we have more green and this curve goes up. And you can do several tests, and there's a red triangle with several options. So I can ask for an RC curve, for instance, and this also gives me the area under the curve, which is nice for comparison purposes and diagnostics. Okay, so I close this Fit-Y/X output, but I keep the table open because I also would also like to use it for data modeling. And this section is about building models, just a short introduction. And we will see that there's again one generic platform, FitModel, which provides many different options. And the options for modeling include ordinary least squares, but also stepwise regression, generalized linear models, mixed models, generalized regression, including penalization and also generalization, so using different distributions. So many flexible options just provided by one platform, FitModel. And this platform can be also found on the Analyze menu, but I will just run a script we have here, and this calls the FitModel platform, and we directly see the outputs. By the way, if you run a script, if you are at a certain point in your analysis, you can also ask for what was the starting point in configuration. So if you relaunch this analysis, you see, hey, this was the FitModel platform, and dissolution was used as a continuous response, and these are our modeling effects. And on the personality, there you see the many options this platform provides, and we just take the default one chosen for a continuous response, which is ordinary least squares regression. So I go back. So this is the output, the actual by predicted plot, quite useful. We see a ranking of our model effects. So the most significant on top, which is screen size, the least significant, which is an interaction at the bottom. And if you want to get a simpler model, you can just remove this manually, and then everything else is recalculated and updated right away. You can also undo or add other effects. So this is also an interactive and manual variable selection technique for modeling. There are some diagnostic outputs and the effects, and finally one really exciting and very popular tool, the profiler, which visualizes the model, and we see the predicted dissolution on the left for certain settings of our factors from mill time to spray rate. These are the 5 factors which are in our model. And we see that there is some curvature for mill time. There are linear relationships for these factors, and there's also a categorical factor, which is screen size. So you see, you can also change one factor at a time and ask, hey, what does this mean for our response? And you see if coding viscosity goes up, the response goes up. But if you look at the factor spray rate, you also see the interaction that changing one factor also changes the effect on our response on another factor. So that's the interaction which is in our model between coating viscosity and spray rate. And there's also an interaction profiler which also shows you some more details about interactions. The profiler also allows you to optimize the settings. So here we see what we want, and this is our desirability, which means the higher the dissolution, the better. So we want to maximize this. And if you ask for maximize the desirability, this will find the best settings to maximize dissolution. Yeah, and this is the best dissolution we can get from this model. And these are the settings to get this best setting theoretically. If you're interested in practical outputs, and if you want to add some jitter and stochastic variations to your factors, maybe you cannot guarantee a mill time of this value all the time. So then you can also add a simulator which does some Monte Carlo simulation, and there you can specify and add some randomness to your factors. Maybe screen size can be fixed, but all the other factors have some randomness. You can also specify in more detail, of course. And then by simulate, I do Monte Carlo simulation. So this does 5,000 simulations by default. And 70, that's our lower specification limit. So if you simulate, so the data points down here, so that these are the out of spec data points and the problems you want to avoid and minimize. Now, when you're done, you typically specify, save the prediction formula. You can save this to the data table, or you can also publish a formula from a model, and then the formula depot allows to export the model in different scoring codes or different languages, as you see here. There are many ways to build models in JUMPs. So there's also a model comparison platform, and this also allows you to combine models to meta or ensemble models, which can be better than any individual model. So that's also a very sophisticated approach to improve your model. Okay, so while the topics so far from descriptive and univariate statistics to multiple regression models can be considered as a standard agenda in engineering, the following brief topics and demos point you to additional themes or topics which are also relevant for the engineer of tomorrow. And they include nonlinear modeling, survival and reliability, DOE, and some quality and process tools. So let me start with non-linear. So looking at the Analyze menu, you see that there are more modeling options in addition to fit model, where we saw all the personalities already. So there are also neural networks, tree-based models, including random forest, boosted trees, and many other ways to build models. And I would like to point you to some specialized modeling methods called fit curve and non-linear. So let me open this example here, and if we take the y and the x into the graph builder, we see that this is definitely not a linear relationship. So we need some other modeling techniques. Linear would not work. So you could use the fit curve platform and try built-in models from a library, or we can also take the nonlinear platform, and this platform asks for the y, the response, and an x. And for the x you have two options basically. So again, you can use a model library, a built-in one, and I can also test this and check the parameters for different models. So you can pick a model from that library, or you specify a formula. You specify the model with the prediction formula in your X column. And that's what we have here. So nonlinear plus, the plus tells us there's a formula on the nonlinear column. And if I click on the formula, here we see the formula. We have the X, and this is nonlinear, of course, and we have two parameters, B0 and B1, with two starting values to start with, just a best guess. And the nonlinear platform will fit these parameters to our data. So nonlinear, that's the one with the formula. We also see the formula down here. And then I click OK, and we see the plot, and I click Go, and then we see the good news. So this one converged, and then you see the plot, you see the model, and you also see the parameters, and you can check the solution. Right. So the next topic is one example from survival and analysis, and here we have a very special data set. It's not special for reliability, because there it's typically common that you don't exactly know when a certain system failed. And here we have also failure times, but we have interval censored data. And that means that we don't know exactly when these 839 microprocessors failed. So we know that they were still working after 48 hours, but they must have failed later, but we don't know when. So the end time is missing. Yeah, and that's one type of censoring you can specify in JMP. And let me just run this script here. So the censoring is also shown on the event plot. Yeah, so here we see the number of observations, the frequencies, and then the triangle means censoring. So for these two processors, the line 9, we know they were still working after 500 hours, but they failed before 1000 hours. So in this dotted period, the failure occurred, but we don't know when. Yeah? And JMP can handle this uncertainty, and you can model your data and add distributions and use different scales. So here we look at the non-parametric case, and you get a Kaplan-Meier curve, but you can also fit a model like a Weibull distribution, and you can also change the scale, and then the model changes into a straight line, and you can maybe easier see how the data fit that line. I can also add other models, log normal for instance, and then you get the outputs and statistics for all your different models, but you also get a summary and comparison where you can pick the best model. Or you just ask JMP, so in this case, what is the best distribution? And the winner in this case, according to this ranking here, is the Weibull distribution. And you get a distribution profiler. So we see the probability for failing after a certain time. And you can also go down, and there are also other profilers like the quantile profiler. So here we can see the median failure time, which is given here for our data, based on the Weibull model in this case. So there are many more options on the reliability and survival menu. So for instance, there's also fit live by X if you have one factor, so that can be used for accelerated testing. There are degradation, destructive degradation analyses, and many other platforms. Next topic, design of experiments. So the needs for engineers with DOE skills cannot be emphasized too much, and unfortunately we only have a few minutes to mention this topic, but you will probably agree that one factor at a time testing is really old school, and teaching some traditional designs like factorial, fractional factorial designs and other traditional screening designs is maybe a good starter and a nice teaser for your students. But however, you should not miss teaching what's most used in industry today, and that's an optimal design. And maybe even if you take a catalog and the best choice from a catalog or a textbook, it may not be optimal. But the flexible custom designer, again the first option on the DOE menu in JMP, gives you the best design for a given problem, and this in a very flexible way. So as one example, let me open this data set here. So this is a chemical reaction experiment, and % reacted, that's our response, which was already measured. So the experiment is done and the measurements are already added to this design plan. So the other 5 columns, these are our 5 continuous factors. And in JMP, so you can always go back to the design phase, and I can do this by a single click, and we see the design dialog, and you see this was the custom design tool which was used here, and the response specification, we see the factors with their low and high values, 5 factors. There were no constraints, and we see what this was built for. So what did this user want to learn from the experiment? So the model specification says we are interested in the main effects, and we are also interested in the 2-factor interactions, but not in any curvature or higher power terms. And then you get the design, and you also get some evaluation output you can consider. For instance, the power analysis, which is quite interesting and helpful. You can look at the prediction variance surface, and very important also to compare designs. You can check the aliasing matrix or also color map on correlations. And there you can see the biasing of other effects on certain, maybe the main effects. And this is also interesting to check the terms and effects which are maybe not in your model, but which could bias the effects in your model. So that's definitely an important output to consider. And the design tool also creates the analysis step for you. So by a single click, for instance, on screening, I can analyze the data, and screening would do some variable selection for me, and I can just run the model from here. Or I choose model, which is fit model, and I just run this. So it's all pre-configured based on the specification we made during the design, and we are all set to analyze our data. And here we can again manually remove some effects from our model. So if you see a hat sign, this tells us that this effect is used in some more significant terms. And so you can remove terms step by step, and maybe now we have only effects which are all significant. So that's maybe a reasonable model to use for further analysis. And we have three factors left, these ones down here. And again, you see the relationships. They are all linear because we have no power terms in our models yet. And you see also the interactions. And you see the goal of that experiment. It's a maximization task again. So a next step could be to augment this design, and add some more runs, maybe also to learn about curvature before you do an optimization on the profiler again. And again, I would like to point you to the help where you find books. So there's a book about reliability and survival methods, but also another book about design of experiments. And this book has almost 700 pages. So many great examples. It covers all the different ways to build experiments and designs. And it's a very, very useful, very powerful resource as well. Finally, the last topic are some quality and process tools. Just a quick demo, maybe most important for engineers. Check stability, statistical process control, and look at control charts. And I would like to show you how easy it is in JMP to create control charts. So on the quality and process submenu, it's the first command, another builder called control chart builder. And this is also a drag and drop tool. So we measured this per day. So I add day to my x-axis, and this automatically changes to an X bar and R chart. And I can also add more information. So for instance, phase, and again, this confirms the same output we saw earlier, that the spread could be reduced from phase 1 to phase 2. But I can also compare different operators or the variability for different machines just by drag and drop. So there's, let me get the face back. So there's also the right click again. So for instance, I can switch on tests, and this gives me some warnings and some hints for some special courses you typically want to eliminate and avoid, so that you have a stable process, and then you typically move on and ask about what about the capability of this process. So capability requires some specifications, typically given as specification limits. You can also add to a JMP data table and to columns as properties. And let me show you an example here. So there's also another platform process capability. So this is semiconductor process data, but we have many processes, as you see here. And process capability gives an overview about all the processes, and I can color the goal plot, and you get the indexes, so CPK, PPK, and the green zone is where you want to be. And if a process is more on the top, you have a problem with variation. If a process goes or moves to the side, you have a process with location, with the average. And so that's maybe the case here, but you also have a spread problem, variation problem for this process here. And you also get capability box plots, which allow you to compare the goals and the specification for all the processes, and that's a nice overview as well. And I can also ask for individual reports. So here you see where the lower and upper specification limits are and our target, and we see where the data are, and then you can see the non-conformance. So this is not bad, but you will see non-conformance and also capability indexes like shown in these tables here. Another option is a process screening. So this also gives you a nice overview where you can check both in one graph. You can check the stability of your processes and the capability. And then you can classify your processes and find the processes right away you should focus on and try to improve. And the last topic is about measurement systems analysis. So all these studies make no sense if you look at noisy data and if you don't see the signal. So you really want to see the signal before you look into stability and capability, before you optimize anything. And to ensure this, a measurement system analysis is a good idea. And I take another data set to show you the last example. So here is a script as well. So this is a variability chart. And this is very nice to see where the variation in our data comes from. So from different instruments, from different operators. And for instance, we see that Janet using instrument number 4. So she really has a problem with spread and variation. So there's a lot of spread and probably noise here. And then we are interested in some studies. So there are also modern methods in JMP like EMP from Wheeler, which is the evaluating measurement process approach. But this is a more basic one, but it's also very useful to see where the variation is coming from. So here we see the variance components of our data, and we see that 98% of the variation is coming from repeatability, reproducibility problems. In this case, the repeatability really causes a problem. And only 1% of the variation is the part-to-part variation, our signal we want to measure. So this is definitely more than a warning and a hint to focus on measurement systems, the process, maybe train the operators. And measurement system analysis is also supported in several different ways in JMP. So what did we cover? We started with some foundations of engineering statistics, from summarizing data to linear modeling And then we also saw some short examples about nonlinear modeling and reliability or event data analysis. We looked briefly into DOE and also saw some quality and process tools. All these methods are found in JMP, and JMP is widely used in industry. But with its intuitive interface and all the free resources, JMP also makes these concepts accessible, very accessible in the classroom.